Hi! Our learning target today for lesson 1 is actually 2 learning targets. We need to learn about sequences and about digits. So, sequences are not the sequins, not the bright sparkly things that are on clothes to make them look pretty, but sequences. I'm trying to fix the screen here. I see that it's not all showing up, so that's what I'm working on. Okay, so a sequence is something that is in order. It's an ordered list. And early on in life, we learn how to count, and that's kind of our first basic sequence. If we count by ones, we say the numbers 1, 2, 3, 4, 5, 6, and so on. We call these counting numbers. We can count by numbers other than 1. For example, we can count by 2s if we say 2, 4, 6, 8, and 10. The first 5 numbers, if you're counting by 2s, are shown right here if you needed to follow along visually. I'm a very visual person, so I like to see everything. I know most of you, when you learn to multiply, you learn to count by numbers. So for example, if you were trying to multiply 2 times 3, you learned to count by 2s 3 times. So you would have said 2, 4, 6, and then you would have known, oh, 2 times 3 is 6. So counting by numbers is very natural to all of us because we've done it for so long. So if we're counting by 5s, that's a very common one. It's very easy, quick to do. 5, 10, 15, 20, 25, and so on. Also counting by 10s. But we can count by anything. And we also don't have to start at the number we're counting by. I could count by 2s and start at 3. And if I did that, I would be saying 3, 5, 7, 9, and so on. So, we're not always starting at the number, just to kind of keep that clear. I know the book is showing starting at that number just to keep things simple, but we can be a little more advanced. So, a sequence, again, is an ordered list of numbers. And each member of the sequence, or each number in the sequence, we actually call a term. So that's this word right here, T-E-R-M. If we study a sequence, we can figure out the pattern or determine the rule. And once we determine the rule, we can use that to find more terms in the sequence, which is what you're going to be asked to do in a lot of your homework questions. So let's go ahead and take a look at example 1. If you have your book out, you can take a look at that because this is just directly from that. So they give us the first 3 terms of a sequence, and they give us the numbers 3, 6, 9, and 12. And they ask us to find the next 3 terms in the sequence. Now, if we look at the sequence, we can see that the numbers are increasing. They're getting larger. So that means this is a sequence that is counting up or adding. What we need to figure out is how much is it going up by. So some people can look at it and they know right away, oh, it's going up by this, because they're familiar with the counting pattern or can subtract quickly. But if you're struggling with that, you have to do a little more work. And this is an easy one. And you need to be able to know what to do when it's one that's not so easy. So we'll go through the method anyway, even if you know, oh, I know it, okay? So if you didn't know, you would need to look at the first 2 terms and find the difference between them. Now, difference means to subtract. So we would really do 6 minus 3. And most of you can do that in your head, but just so you can see what we're doing 6 minus 3, which is 3. So the difference between the first and second term is 3. Now, if we look between the next 2 terms, it has to be the same in order for the rule to really apply. So we have to make sure that rule works for more than just one pair. So we look at 6 and 9. So we would say, all right, let's make sure it works. 9 minus 6, what is 9 minus 6? That's 3. So it works. So the rule is definitely counting up by 3. So sometimes we just say plus 3 is the rule. And now we need to use that rule to find the answer to what they're really asking us, which is to find the next three terms. So then you would just continue going on, 12 plus 3, which is 15, and then 15 plus 3, which is 18, and then 18 plus 3, which is 21. Now, all of my fifth graders have math pages or reference sheets, and on the very first page is the multiplication table, and it has quite a few of that. Now, one way you can use this is once you know what the rule is, if it's counting up by 3, you can go to the 3 row and follow it across. And what you'll see is they have some of the terms that were given to us, 3, 6, 9, 12 shows up, and you can keep following it to find the next three terms. So 15, 18, 21 were the next three, and that's what we determined already. So these multiplication charts or reference sheets can be very useful and make your work quick. When you're working at school on your desk, there is a multiplication chart right there, so you can use that one right there. Also, you don't have to just go across on the row. You could go to the 3 column and follow down. So it doesn't really matter if you go across or up and down, but this can be very quick. All right, let's look at another example. Oops. Example 2 asks us to describe the rule for the counting sequence below. What is the next term in the sequence? So they give us the terms 56, 49, and 42. So when we look at that sequence, we can see that the numbers are actually decreasing this time. So instead of counting up, they're actually counting down. So instead of adding, we must be subtracting a certain number. And we need to figure out how much is being subtracted each time. So some people can look at this and recognize, oh, I know those numbers. I say them when I count by, and then they know. If you don't know, you have to do the math. So you would take the first term and the second term and subtract them. So we would do 56 minus 49, which I know in my head. Hopefully as fifth graders you do, but sometimes we need to work it out. So we can see we can't do 6 minus 9, so you have to borrow. And so then you end up with 16 minus 9, which is 7. And 4 minus 4 is 0. So I'm not going to write that down. So this shows me that the rule is counting down by 7. I need to make sure the rule works. So I need to check the next two terms. And I would say, okay, 49 minus 42, it better be 7. But if it's not, then I know I didn't really find the right rule. It's not counting down. But if we look at 9 minus 2, that is 7, and 4 minus 4 is 0. So it's 7 both times. The rule works. So they ask us to describe the rule, and usually when we describe, we use words. So we would say, counting down by 7. However, mathematicians usually like to take shortcuts. So instead of writing the words counting down by 7, we could say just minus 7. And sometimes that makes things a little shorter. Okay. Now we still haven't finished because really this is a two-part question. We also need to find the next term. So 42 was the last one given to us. We need to take 42 and subtract 7 to find the next term. And I'm out of room on this little whiteboard here, so I'm going to subtract that other, get rid of that other work, and then do 42 minus 7. And I know what it is, but if you need to do the borrowing, that's fine. You can do that. We get 35. So the next term is 35. Okay? Oops. Now you can see it. Now, you can use your reference sheets for that also. Once you determine that the rule is counting down by 7s, you'd use it a little different when you're counting down. So you would still go to the 7 row because it was by 7s. And this time you're going to follow it over to where the sequence started. And it started at 56. So I'm going to follow all the way over to 56. But now to determine the next term, I'm going to go backwards. Okay, so then I would follow backwards and see that the next term is 49, and then backwards again, it's 42, and then backwards again, it's 35. Okay? If you're struggling with figuring out how to use the reference sheet, when you come back to class, you can say, you know, I know you were explaining that, but I didn't really get how to do that. Can you show me? And I will gladly show you. Or one of your group members could probably show you also. Okay, so moving on to our second learning target, we are supposed to be learning about digits. Sometimes people say their digits are like their fingers or their toes. However, in this case, when we are talking about digits, we are actually talking about a symbol that we use to write numbers. The digits that we use in our number system are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. We use those digits to write any numbers. So if we take a look at this number, 385, it actually has 3 digits, the 3, the 8, and the 5. We would say that the last digit is 5. So whatever number in this case is in the ones place is the last digit. The book might ask you questions asking how many digits does a number have. So for example, you look at this number, it's a rather large number. You just need to count how many digits there are. You could count individually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or you could see the commas separate the groups of 3 and count by threes. 3, 6, 9, 12. And so this number has 12 digits. The last digit of the number is 4. The first digit would be 1. Later on in the year, the book will ask questions such as which digit is in the tens place, or which digit is in the thousands place, or hundred thousands. We will get into that when we learn more about the place value. So let's take a look at a couple of examples. Example 3 gives us a number and asks us how many digits are in this number. In class, I would normally ask who knows how to read this number correctly. So you can look at the number and think about it. And if we read this number correctly, we would say 186,000. To answer the question, how many digits does it have, we need to see how many digits there are. So we take a look. 1, 2, 3, 4, 5, 6. And even if a digit is repeated, we still count that as another digit, okay, because it's shown up and used in the number. So to answer this question, we would just write that it has 6 digits. Okay. Taking a look at example 4, it asks us what is the last digit of this number. Now I want you to take a look at that number and think about how you would say that number correctly. So that number is read 26,348. And if you look at the last digit, you're really looking at the number that is in the ones place. So that is the 8. And we would say that the first digit is the 2. They don't ask us that, but just to add in another part. Okay, so now we're going to take a look at some practice questions. I will do a couple of them together with you, and then I'm going to ask you to try a couple of them on your own and try them in your notebook. I'll give directions for that in a minute. And then we'll come back to school and talk about what you came up with and things that you understand or don't understand. And we'll do a few more in class so I can make sure you watch the video and you understand what you're supposed to know for this learning target. Okay, so you should have your notebook with you. I reminded you to put it in your backpack. And you need to open your notebook to the first blank page. We haven't used it yet. Okay. And what I would like you to do on the margin in the side, and you probably won't be able to read this, but I wrote PS1 for problem set 1, and then I wrote the date underneath, and I just wrote 8/23/13. You might write whatever today's date is, because it could be watching this on a different day, and that's fine. All right, let's take a look at the directions for the first set of questions. The directions say to describe the rule for each counting sequence. Then write the next 3 terms in the sequence. So if you take a look at question A, they give us the terms 6, 8, and 10. Those are the first 3 terms. So we need to take a look at the pattern. You can see that the pattern is increasing. So it's counting up. I can quickly see how much it's going up by. I think you probably can too. You can see that it's going up by 2. Excuse me.